Hi everyone, Miss Sharina here, and this week we are going to continue looking at constructions, and we're also going to look at some characteristics and properties of 2D and 3D shapes. Okay, so we're looking at something called congruency. So what is congruency? So two shapes are known to be congruent if they're exactly the same size and shape. For example, these triangles are all congruent because they're all the same size and they're all the same shape. Okay, notice that the triangles can be differently oriented. You can place them in different orientation. It can be reflected, it can be rotated, but as long as they are the same size and shape, we say that they are congruent. And then we also look at nets of solids. Okay, when we have 3D shapes, we can sort of figure out what the net solids are. Okay, so for example, when you cut open a box, you end up having something that looks like this. Okay, and this is what we call the net shape of the box. It is a 2D plan of the 6 faces that join together to form the box. So it's like you're opening up a 3D shape. Okay, so for example, a cube. If I were to open up a cube, I will have something that looks like this. And this is the net of a cube. A cube has 6 square faces, so the net has 6 squares. Okay. So there are quite a lot of different nets that make a cube. And so I can have one of them like this. I can have one of them like this. And another one that looks like this. But they all make up a cube. Okay, it's just that the squares are in different arrangements. Okay, so you can actually test them by actually trying and drawing boxes in this orientation and try and fold it up and see if you actually get a cube. Okay, and then we look at symmetry. When we look at symmetry, it's basically we are talking about a line that can be drawn through a shape so that what can be seen on either side is a mirror image. So sometimes we call it a mirror line. So basically, if I cut this smiley face into half, both sides look exactly the same. So that's what basically symmetry is. So my line of symmetry is in the center. If I cut it like that, I will have both sides looking exactly the same. But for in this case, this smiley face, there's only one line of symmetry. I can't cut it any other way where I can produce the exact same mirror images of each other. There are some shapes that don't have lines of symmetry as well. For example, this shape. Okay. Then we look at rotational symmetry. Okay, if you see the square is being rotated. Okay, so as we say, a square has a rotational symmetry of order 4. So what this rotational symmetry is, it's basically how many times a shape can be rotated and fit within itself. So how many times a shape can be rotated, and no matter how you rotate it, it will look exactly the same. So like the square just now. And if we look at this triangle, okay, if you rotate it in these 3 ways, you will still have the same shape. So we say an equilateral triangle has a rotational symmetry of order 3. Why order 3? Because the 3 different orientations, all 3 will look exactly the same as the original triangle. So for this shape, it has to be rotated 1 complete turn before you get back the same shape. So we say it is order 1. Okay, if I were to rotate it this way and stop here, it won't look like the original shape. So it has to go 1 round before it looks exactly the same. So we say only 1 rotational symmetry. So we say order 1. So that is all that we are looking at this week. So I will see you guys in class. Okay, bye-bye.